In the previous lectures, we have learned frequency distribution and quantiles, including quartiles and percentiles. They sound different and they look different, but actually they have something in common. Set the boundaries to grouped data in. In this lecture, we are going to find another way to set the boundaries and grouped data in. This is our data set. We are very familiar with. The mean of this data set is 82.8. The standard deviation is 9.1. Let's be creative and innovative. Let's find a unique way to set the boundaries. Uh, the thinking is, hi, how about I set a boundary is the mean minus one standard deviation. That means 82.8 minus 9.1. We got this number 91.9, and we set another boundary is the mean plus 2 standard deviation. We got this number 101, and the third boundary is the mean plus 3 standard deviation. We got this number. On the other hand, this boundary is symmetric to this one, and is the mean minus one standard deviation, 73.7. This one is symmetric to this one. It is the mean minus 2 standard deviation, and so on. This one is the mean minus 3 standard deviation. By this way, we actually not only set the boundary, but also set a kind of scale to measure the data. The middle point of the scale is the mean. The unit is the standard deviation. Now we have this boundary. Okay, we already set a scale. Let's line a scale. Oh, sorry, the line is not so straight. This is the middle point. It's the mean. The mean plus one standard deviation, the mean minus one standard deviation. Keep going on. We got this different kind of boundary, and then we are going to group the data in this class interval or categories. How many data points fall into this one? Actually, we already use Excel to calculate it, and this is data virtualization. I'm going to teach you how to make this graph. But now we know this. We have 5 data points fall into this category, and we have 3 fall into this one, and one data point fall into this one, and this one we have 0 data point. This one we have 1 data point, and we also can summarize it. 8 data points fall into this category. What is this category? This is the mean, the boundary. The left boundary is the mean minus 1 standard deviation. The right of the right boundary is the mean plus 1 standard deviation. Not 80% of the data points fall into this category. 90% of the data points fall into this category is mean minus 2 standard deviation, mean plus 2 standard deviation. All the data points fall into this category. It's the mean minus 3 standard deviation, the mean plus 3 standard deviation. So this summary gives me the information. This data point are pretty concentrating. Most of the data, 80% of them, fall into fall close to the mean. This kind of tools is the original sort of a very famous distribution. It is called normal distribution. Before we go to the normal distribution, let's learn some different denotions and formulas. At the first lecture, I already point out that there are 2 categories in statistics. One is descriptive statistics, the other is inferential statistics. Accordingly, there are 2 sets of formula or denotions for these 2 categories of statistics, because the mean and the standard deviation are the most basic and important statistical tools. So I only list these 2. So sample mean, look, different. The denotion is S bar. Population mean, use mu. Simple standard deviation denotion S, little s. Population standard deviation sigma, little sigma. Let's come to normal distribution. What is normal distribution? Simply speaking, is a bell-shaped curve. Three important features. One is about 68% of the data points fall between the mean minus 1 standard deviation lower boundary, the mean plus 1 standard deviation. It is the higher boundary. About 85% of the data points fall into this category, fall into the mu minus 2 standard deviation, mu plus 2 standard deviation. About 99.7% of the data set fall into this class interval, mu minus 3 standard deviation, mu plus 3 standard deviation, because this curve is a bell-shaped curve. It is symmetry about the mean. So actually, we have another or the first feature of normal standard deviation is 50% of the data points fall behind or fall below the mean, and other 50% of the data point fall above the mean. This information or these characteristics are very powerful, especially in finance. For example, from historical data, 1926 to 2012, large company common stock, SP 500, the average return, the mu, is 11.7%. Standard deviation is sigma equals to 20.2%. These two numbers are pretty easy to calculate. Actually, the study show that this historical data, the distribution is very close to standard, close to normal distribution. So from this sample, we can generalize these characteristics to the whole population. That is why use the mu. This is population mean. Use sigma. This is population standard deviation. Anyway, we only have these two numbers, but this is very powerful information, because what these two numbers mean? Because we know 60% of the data point fall into this glass fall into this class interval. That means mu minus 1 standard deviation, mu minus plus 1 standard deviation. This is negative 8.5%. This is positive 1.9%. if you are going to buy to buy SP 500 large company common store next year 2019, you need to have the expectation or have the mindset that that your return the possibility of your return 68% chance you are going to have return from negative 8.5 to 31.9%. If you are going to buy large company common stock for 10 years, now you have 10 data points. That means you are going to expect 10 data points, 68% of 10 is 6. That means you are going to have about 7 years. 7 years. 7 years, your return is going to fall into this category. But we are more interested in this point. Which point? This one. This point is mu minus standard deviation over 2. We know the standard deviation is 20.2%. So the mu minus this one is 10.1 is we got 1.6%. Yeah. This is the mu. So because we have this percent, so this is a very important point. This important point tells us this is 50%. 50%. This is about 34%. Half of that is 17%. So 17% plus 50%, we got 65%. What this means? Why I care about this point? Because this point is we have at least has a little bit, at least very close to 0. That means we at least has some earn some money. Generalize the normal distribution information to real life investment. One data point. If I'm going to invest in large company common store next year, I only want to invest 1 year. So we only got one data point. Then that means you are going to have 67% chance to at least earn some money. At least earn some money. The second application is if you are going to invest in large company common store for 10 years, begin with next year for 10 years. Now we have 10 data points. This percent has another interpretation for their 10 data points. The interpretation is you are going to invest for 10 years. That means 6.7 is about 7 years you are going to at least has positive return and money. 7 years and money. About 3 years lose money. This is the normal distribution function. I think the idea of normal distribution is pretty easy to understand. You just build a kind of special skill to measure the data and set the boundary according to the mean and standard deviation and group the data in. Wow, but finally we got this function. Looks very complicated. Fortunately, you don't need to learn this function, but you better know. Oh, this is the function of normal, the probability density function of normal distribution.